Imagine walking into a brand new building. The paint looks fresh, the floors shine, everything appears perfect. But hidden inside the concrete, there are tiny mistakes made on the very first day of construction which have already started a countdown to failure. Not because of earthquakes, not because of old age, but because someone added a little more water, skipped proper curing, or ignored a quality test that seemed unimportant at that time. The frightening reality is this: most concretes doesn't fail till years. Here, when the mistakes are done, it begins failing the moment it is poured, and by the time cracks become visible, the damage has often been developing silently for years. Today, we are uncovering one of the most expensive and preventable mistakes in construction, that is, poor quality concrete. Every skyscraper, every bridge, every industrial plant, every hospital, every home shares one thing in common, that is concrete. It is the foundation of modern civilization. In fact, concrete is the most widely used man made material on the earth. Every year, billions of cubic meters are placed around the world. Yet, despite all technological advances, poor quality concrete continues to be one of the leading causes of structural deterioration, costly repairs, project delays, and even catastrophic failures. The surprising part: concrete itself is not the problem. Poor engineering decisions are. In this episode of Sunex Building Construction Intelligence Survey Intelligence series, we will explore what makes concrete strong, why quality matters, the hidden mistakes that shorten a structure's life, and how builders, engineers, and project owners can prevent these failures before they happen. Whether you are an engineer, contractor, developer, project manager, or someone simply planning to build your own dream home, this episode could save you years of problems and potentially millions in repair costs. Let us begin where every successful structure begins, with concrete itself. Concrete, the foundation of modern civilization. When people admire an impressive building, they usually notice the structure and the architecture of the building. The glass, the steel, the elegant design. Very few people stop to appreciate what is actually carrying all that weight, that is concrete. It's easy to think of concrete as just a mixture of cement, sand, and stone, but in reality, it's the one of the most carefully engineered materials ever developed. Concrete is a composite material. Every ingredient has a specific purpose. Cement acts as a binding agent. What triggers is the chemical reaction known as hydration. Fine and coarse aggregates provide strength, stability, durability, and volume, and modern admixtures allow engineers to improve workability, durability, setting time, and resistance to harsh environmental conditions. When these ingredients are proportioned correctly, they create a material capable of supporting enormous loads for decades, sometimes even centuries. Think about famous structures like dams, airports, bridges, tunnels, and high rise buildings. Their long performance is not simply the result of using concrete. It is the result of quality concrete. Now, here is something many people don't realize. Concrete does not actually dry, it cures. That's the important difference. Concrete gains strength because of the chemical reaction between cement and water. This reaction continues long after the concrete appears hard. In fact, properly cured concrete can continue developing strength for weeks and even months, which means the very few days after pouring are among the most critical in the entire life of a structure. Ignoring this process is like planting a tree and never watering it. You can't expect it to grow. The same principle applies to concrete also. Quality begins long before the structure is occupied. It begins during the very first hours after placement. Quality begins long before the structure is occupied. It begins during the very first hours after placement. Engineering insight. Experienced engineers often say concrete remembers every decision made during construction. Every shortcut leaves a permanent signature inside the structure, and eventually the signature becomes visible. Viewer engagement. Have you ever seen a building develop cracks? Just a few years of construction? What do you think caused it? Share your thoughts in the comment. Transition. Understanding what concrete is the only beginning. The next question is far more important. What actually determines whether concrete becomes incredibly durable or disappointingly weak? Let's find out. In the previous slide, you have seen concrete is the foundation for modern civilization. As already we have understood that concrete is a versatile material which is composite and made up of cement, water, fine aggregates, such as sand and coarse aggregates. Concrete is the world's most widely used building material due to its adaptability, fire resistance, and strength. Its performance is defined by properties like workability, consistency, and durability. You have seen that the coarse aggregates and the fine aggregates, they occupy about 70% of the total volume of the concrete, and up to 18 to 20% is occupied by the cement. Remaining will be occupied by water, admixtures, and the voids. Cement is the binding material which binds and combines all the components together, and water is the main ingredient which reacts with the cement and causes the hydration reaction, which in turn makes the concrete very strong. And admixtures are these are the additives which modify the properties of the concrete in terms of strength, in terms of setting time, in terms of durability, in terms of extended life of the structure. The anatomy of quality. What is the quality? What is the procedure to maintain the quality of the concrete throughout its period of mixing, placement, curing, and final compaction? Imagine two identical buildings, same architect, same structural design, same contractor, same materials. All are same. One building lasts over 70 years with minimal maintenance. The other begins showing cracks, leakage, and deterioration within just 10 years. What made the difference? Not luck, it is execution of the structure. Quality concrete is not created by accident. It is produced through discipline at every stage of construction. Let's begin with the first stage, that is mixed design. One of the most important engineering decisions is the water cement ratio. It sounds simple, just add water, but here is the surprising part. Adding extra water may make concrete easier to pour, yet it also creates tiny pores inside the hardened concrete. These microscopic pores reduce strength, increase permeability, allow moisture to enter, and accelerate deterioration. A small shortcut today can become a massive repair bill tomorrow. The second stage is placement. Concrete must be transported, placed, and compacted properly. Improper placement leads to segregation. Large aggregates settle, cement paste separates, air becomes trapped. These hidden voids become weak zones inside the structure. They are invisible from the outside, but under heavy load, they become points of failure. Then comes the curing part, perhaps the most neglected stage on many construction sites. Some contractors remove curing water too early. Others stop curing just after 2 to 3 days. But concrete needs time. Without sufficient moisture, hydration slows dramatically. The result, lower strength, higher shrinkage, surface cracking, reduced durability, and a shorter service life. Think of curing as investing in the future of your structure. It does not make the building look better today, but it determines how well it performs decades from now. Engineering myth. Many people believe stronger concrete simply means adding more cement. That's not true. Excellent concrete comes from the balance, correct proportions, proper workmanship, and rigorous quality control, not excess materials. Practical lesson is concrete quality is built through thousands of correct decisions, not one expensive material. Transition. Even when engineers understand the science, quality can still be lost if no one verifies the process. That's why every successful construction project depends on something even more important than good intentions,